Hello, everyone. We are getting set up to start recording in a few minutes.
There we go. How many of us are here?
Looks like two youth are signed in right now. So that's it. So we'll give it a few more minutes and see if we get some more kids to log in. We'll start in maybe 3 or 4 minutes. How's that sound?
Sounds good.
All right. Well, I'm thinking this might be a smaller group today than last time, but we've got the recording going. So we'll be recording the session and putting it up on the YouTube channel. If you all can actually go in and turn on your video, and then let's go ahead and hit the 3 dots in your little video window. If you scroll over your window, you'll get 3 little dots that come up. And I'd like to ask you all to rename yourselves with your first name in that, so that Zane and I and Mary Louise can easily address you and remember your names. So if you don't have your first name in there, go ahead and rename yourself so that we can see your name and call you out. Wyatt's gone ahead and done that. Caden's done that. All right. Awesome. Oh, we have another one. Christina's coming back in here. Let's see whose kiddo is that.
It's Jeremiah.
Oh,
So maybe you could rename him since you're
so
host.
I don't know if Jeremiah. How do I spell that? Jeremiah.
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 Yep.
Right. Okay. Awesome.
Thanks.
Wyatt and Caleb and Caden. All right. So we got our crew here today. Hopefully we'll get some more people connecting here soon. Just wanted to connect with you all today. And first off, we're going to see what you all have done since the last time we saw you last week. Have you worked on your robots?
Show us, Caden. What'd you do? Please.
Unmute yourself, please.
Well, I've just kind of remodeled it. I put a couple of sensors on there.
What sensors did you put on?
I put the voice sensor and then the touch sensor on there.
Excellent. Awesome. All right. So Wyatt and Caleb, did you guys do anything on yours since last week?
I haven't worked on my robot this week, but I did make a presentation for Showcase Showdown.
Oh, awesome. That's good. How did that go? How did your presentation go?
I don't know yet.
Oh, you haven't gotten your results yet? How do you feel you did?
Really good.
Excellent. That's good to hear. I'm glad to hear that.
So
All right.
what did you do it on? Did you do it on robotics?
No, I did it on Legos.
Oh, you did it on Legos. Okay. Well, Lego
So robotics did have a whole slide on it.
Okay. That's cool. Excellent. And how about
Caleb,
your
did you
little
do
brother
anything
there?
with? Oh, sorry, Jane. Caleb, did you do anything with your robot?
No, I just have mine finished.
You got it
So
finished?
I'm just leaving it pretty much alone.
Okay. Does it have any sensors on it or anything? Or motors?
I used to have every single sensor, but that got too much wire, so I got all the sensors off of it.
Okay, cool. All right, well, that's good. All right, so please unmute yourselves and please go to the 3 dots in the corner of your screen and change your name. Rename your name so we know your name and we can call on you.
That means you, Jeremiah, and you, Ward.
Turn your videos on. Rename your names. Unmute yourself. We can't hear you.
So how do you change your name?
If you scroll over your video in your box, there's a little button with 3 dots in it. Click that button and it says rename. Go down to rename and then type in your name.
Or you can also go to participants and click on your name and rename.
Yeah.
You need to rename
Your
yourself
iPad
too,
has
Ward.
no sound. Uh-oh. Let's see here. Maybe we can ask to unmute. I'm surprised your iPad should have a speaker built in. Or a mic built in. It looks like he froze. Okay. So Jeremiah, have you had any chance to work on your robot since last week? He might be frozen.
I think he froze too.
Ward, have you been able to work on your robot since last week? Yeah, we want you to show it to us. Even if you can't talk, you could show us your robot and maybe type in the chat if you did anything like attach some sensors or something. Oh, awesome. It's getting there, huh? So you have a little bit more to go because you got to get your computer on there. Awesome. Jeremiah, how about yours? Have you been able to work on yours since last week?
Yes, and I started doing my trying to do my own kind of thing, but it was actually getting rickety and everything. So I just basically made what the manual said to do and just build all of that. So that's basically all I have, and I'm just gonna start with that.
Okay, that's the easiest is to start with what already exists and already known, and once you learn your machine, it makes it a lot easier to build with on your own and be more experimental. Switch out the sensors and things like that and recode it. So awesome. Ward, what are you trying to put up there with the number 15? Is that the number of robot you're working on? Yeah, okay, cool. That's the page. Oh, sweet. Okay. Cool. All right. So today really is about helping you guys get to where you need to be. So we need to, you're going to have to communicate with Zane and I about what you need to figure out, where your problem solving is. It's also a good time to talk with each other because as you all are building, you all are solving problems, and one of you may have figured out a solution that not even Zane and I know that you could share with your fellow 4-Hers. So now is really the time to start talking about what is left for you to do and what problems you need to solve with your robot. So that's where we're going to go from here. And you can either unmute yourself and tell us what you're thinking, and we can all kind of put our brains together right now to help you, or you can type it into the chat. Don't be shy.
I haven't really been able to find a working body yet for the robot, and I've tried 2 different robots. Neither of them worked.
And
So
why aren't they working? Are you building your own robot?
yeah, I'm
Okay.
building my own robot.
So you're
And
really trying to customize?
yeah. And see, my first one was more of, I didn't have all the pieces needed to build one of the things on the website. So I took a spin on it and made like a smaller version of the electric guitar one,
Okay.
but it didn't really work a lot.
So, do you have that list of pieces that you need? Because we do have some extra parts and we could potentially loan you those extra pieces.
No, I'm really trying to work on a sumo bot now still.
Okay, so you've changed from the guitar to now a sumo bot?
Yeah, and my first design was like a four-wheeler almost, but it kept breaking because I didn't have a well-built it kept dragging on the floor and breaking.
Okay. So what do you think you need to do to solve that problem so it won't drag on the floor?
I think what would need to happen was I need to flip the motors that I
The-
had.
The servo motors, maybe they were installed upside down or
Take
backwards?
the rubber band, throw it on both of them, and then like throw it on.
Do you want to show us your robot and show us what you're talking about so we can understand better?
Yeah, just a second.
And Caden says he needs help turning.
Oh, okay. Awesome. We will help Caden with learning how to turn. Caden, are you looking at programming is what you need to learn how to turn?
Yeah, in the program.
Okay. Well, I bet Zane is on that already.
Yeah, we can do that. I'll build up a program.
All right.
We could do a breakout.
This is true.
I could have you and Caden and anyone else who wants to work on the turns go into the breakout. What do you need to work on, Jeremiah?
Like what? Like in programming or building?
Programming is what Zane's gonna break out maybe with Caden to work on some programming problem. Unless you guys all
Well,
want to just stay here since we're a small group and go through each of these problems one by one and we can each learn from each other. All right, looks like Wyatt is showing us his robot right now. So explain to us the problem again, Wyatt.
So the two motors in the front, they were dragging on the ground.
Okay. Like in the front part where it's in front of the tire?
No, in the. Can you hold this up? One second.
You could point to it, Wyatt.
It was, I had the tires like this. That way I could have more support to hold the tires together. But this part was dragging.
Oh, okay. So you need to turn it upside down then? Or what?
Yeah, I need to have it like this, but the hard part about this was there's so little room to attach it when you have the motor up here. You can't really attach it up there via this. Here I had a way so the motor could sit like that.
Okay.
And then
So do you have another piece you could put in there to maybe space it to help solve that problem?
yeah, I tried a bunch of things like a rubber band. I tried a rubber band put into the box, but nothing seemed to be working.
Okay. Anyone else have a problem similar like that they might have seen a solution? What's that part?
This was my first robot, the electric guitar one.
Oh, okay. Cool.
Hello. Now you can talk.
Hey, you can talk now, Ward. Awesome. You got your voice. Yay. We can hear you. All right. So, Wyatt, do you need help still solving that problem?
No, I don't think so, because I just decided to start over again.
Okay. Are you following a build direction on how to build it?
No, I'm still gonna go off what I want to.
Okay.
Just trial and error.
Okay. Well, you're learning a lot. All right. So let's talk with Hayden about his turn. Help turning. Zane, what did you find on turning and coding?
So typically with these servos, they're something you have to program is called a tank drive. So it really depends on how your motors are set up. So if I could see how your motors are set up, like with mine here, both of mine are facing the same way. So forward is one direction on both and back is one direction on both. And to turn, I need to either, if I want a point turn, you only move one forward. But if you want a 90-degree turn like that, you need to forward on one tire, reverse on the other. And that just really depends on the setup of your servos.
Okay. Like the orange one's facing the same way, or?
So they both look like they're facing the same way. The fat part of it is facing up, right? The little bulb in the back.
Yeah.
All right, so they're facing the same way. So for you to turn, so say you want to turn left, you're going to want your right tire going forward and your left tire either stopped or going in reverse.
Okay.
So that way the robot can turn either a full 90 degrees as a whole, or it pivots to the left.
You want to
Okay.
show him in the coding how to make that happen and share your screen?
I was trying to share my screen, but I think it's disabled.
Oh, let me unlock it. I'm sorry, that's my
You're
fault.
good?
Okay, it should be open now to share.
There we go. So if we go into Lego Mindstorms here, I was just tinkering with some sensors. Why aren't you dragging out? And then we'll go over here. So you want to go to move, and you want to have two functions. And if you're going to program it to like follow a path and you want it to turn, you're going to want these simultaneous. So if I drag another one out this way, of course, it's not going to connect to anything. So if I drag this one down here, the same position, and I just connect these, this will run at the same time here. So my two motors that I have hooked up into my machine are C and B. So the top one for my left is actually port C. So my top's going to be my left. So we're going to change this to just C. And this is forward or backwards. So if I wanted to turn right, I would keep C forward, which is my left motor, and change this to B only. And if I wanted the whole thing, both wheels to turn, I would set this to reverse. Or if I just wanted it to do point turn, which I would only turn on the right-hand wheel, I would do a full stop. So that's how you would program that in a pattern type program. But if you're doing something like on touch of a certain touch sensor, you would come over here to sensors, and you would just drag in this touch right here. So on touch, and it would complete these functions right here. So
Hello.
So kind of like that. That would be, so like if you hit button 1, whatever that's plugged into, so you can choose the port over here. And if it's pressed in, it'll turn right or left. So that's how you can also program like a button sensor.
Thank you.
Does that help?
Yeah, it does.
Awesome. So who else has a problem or a question? Jeremiah or Ward?
Right now I'm building.
You're building still?
Right now.
Okay. Do you need any help with anything?
No, I'm doing great.
Okay, sounds good.
I'm the best Lego builder out of my sisters and my mom.
Oh, well, that sounds like a skill. All right, Jeremiah, how about you? Do you have a problem or something that we could help you with solving?
I don't think so.
You're doing pretty well.
Maybe a little bit the color sensor.
What did you say, Jeremiah, about your sensor?
Maybe something with the color sensor. If that, I don't know if it's called that, but it's the one that's on the front.
Show us.
Looks like this, has the little things
Awesome.
like that on the end.
Yeah, so you need to learn how to program that?
Well, I don't really know very much about the programming, I guess.
Okay, so Zane, do you want to take them through an intro to the programming and maybe an overview about it again? Would that help you, Jeremiah? And then he can touch on that sensor and put a program into that sensor to show you as an example.
Well, I guess what I'm kind of having a little bit difficulty with is like knowing what certain things are. Some of the things they just show an icon, I don't even know what they're supposed to do. And I was just wondering if we had time, like you guys could, those sensors did maybe.
Yeah, Zane, do you
other
want
than
to
that,
show
I
what
guess-
those sensors do?
I can show them again, yeah.
Okay, sounds good.
So before the sensors, we have the common tabs over here. It's going to be the little circle in the bottom left of this side bar. So you have your move function, which controls your motors. Your record or play, that's going to, I believe, yeah, that's going to be recording the motors in their actions. Sound, that's going to play or emit any sounds from the actual computer on the robot itself. The display, that's going to display images, texts, that other stuff on the display of the computer on the robot itself. We have the wait functions, which you can wait for time, you can wait till there's a touch, you can wait for the certain light, you can wait for a sound, or you can wait for a distance. You have loops. The loop is one function, it just repeats the same function over and over again. And then we have a switch. So this is like either or. You can either do this or you can either do that. Typically, when you're doing strategic-based programming, where you're just teaching it a pattern, you don't use loops unless you're doing a repetitive pattern over and over and over again. So getting into the sensors and more technical side of the computer, we have this panel, which doesn't look as good. It's not as indicative of what there are. So we have advanced functions, so converting numbers to text, text functions, keep alive, file access, stuff that we usually won't use. So you could like calibrating, reset motor. These are all for more advanced functions, which you might get into based on which robot you get into. Here we have data, so this is just like doing math, comparing things, seeing how far something goes, like random numbers, all that type of stuff. And flow, you have more weight functions, you have loops. This is all stuff that was in the last page, just condensed onto this page. We also have a stop function here. Here is where we have our sensors, and we'll get deeper into this section. Here we have actions, which motors. You can do more stuff in motors, sound display, color lamp or lamp. So this is the tab you mainly want to be on because you can access almost everything from this one. And then on the top one, you have your regular common again up here. So getting into the sensors, we have the touch sensor, which let me get out my sensors here. Still working on it. So here we have our touch sensors. They have like a little plus on the front. They're buttons. They do things when you touch them. So that's what this sensor does. You have the sound sensor, which is this one. It's got like a piece of foam or sponge on the inside of it. Kind of looks like a speaker. Here we have the light sensor, which is the one that we're going to be talking about, which is on my robot and on Jeremiah's. There's the ultrasonic sensor, which I have on the top of mine just for aesthetic, but I can't hook it up. There's the Nxt buttons. That's on the actual robot itself on the computer. Same with the rotation sensor. Actually, we don't have the rotation sensor. That's typically called an encoder motor or a regular encoder, and we don't have those. We don't have a timer either. And then the receive message, that's just from Bluetooth. E-meter in and E-meter out, you're not going to have those either. And we have the color sensor. The color sensor and the light sensor are basically the same. They're the same item and object. They just have two different functions in this. And then the temperature sensor, which you guys don't have either. So Jeremiah, are you trying to detect color with your line sensor or color sensor, or what is the function of the sensor for?
Well, I'm just kind of curious about what it was and what it did, because I guess I wasn't really clear about what the certain things did before. So I was just kind of wondering what the certain things did.
Okay, so the touch, like I said, was the touch. The sound sensor takes out or input sound. So like you could probably program your robot. If you like scream loud enough, it'll go forward, and if you speak quiet enough, it'll go backwards. That is the type of stuff you can do with the sound sensor. The light and color sensor. The light sensor aspect, they're both on this piece here. That's why there's two different lights on it. So one of them's a light sensor and one of them's a color sensor. So if it detects a certain light, it can do a special function. If it detects a different color, it can do a special function. So what this one's popular for is, say if I took a piece of black electrical tape and did a path on the floor or on the table, I could program it in. I did this a lot in high school. You could program it in to where it follows the line, kind of like an Ozobot. So that's what the light in the line sensor does. The ultrasonic sensor, it emits sounds kind of like bats, and it comes back at them, and they can determine distance and location with them. So you can say if you get too close to an object, it can tell, and you can tell it to stop and turn around. So that's something that sensor can be used for. The Nxt buttons, those can be used for almost anything. So if you like, while you're running the program, if you press right on the Nxt button, it could turn right or if you turn left, all that. The rotation sensor, that doesn't really have much of a function except for counting rotations and then programming future code to react to those rotations. So say if I were to hook a rotation sensor up to my wheels, and if I were to turn it 90 degrees with the servo on, and it picked up, maybe there was an error in my servo motor rotations counter, and it was actually 89 rotations instead of 90 to get a 90-degree rotation, I would use that information here. The timer, that's just the function. It has a countdown timer. I'm pretty sure that shows up on the NXT screen. I've never used that. Receive message from Bluetooth, that one we don't really have to use because we are hard programming in our computers since these no longer access the Bluetooth aspect in our technology. We don't have e-meters, so you don't need to worry about those. Those typically just, actually I'm not sure what these e-meters do. I might have to research that. We already went over the color sensor, and then the temperature sensor obviously detects temperature in Celsius and in Fahrenheit. What does the conversion? So that's what each individual sensor does. You can do a wide range of things with these sensors. Like I was talking earlier with like these touch sensors, if you wanted to hold them like joysticks, and if you click the right one, it turns right. If you click the left one, it turns left. That's another good one for these touch sensors. But like my line sensor on my robot, since I did kind of a Segway version, I too did my own twist because I didn't have the right parts. So it basically, these are just kind of like training wheels. It doesn't always use these, but when it needs them, it does. But it really, what this line sensor does is it determines the light between the surface and the light sensor itself. And based on that, it can balance itself. So if it's going forward, it's going to be darker, and the line sensor knows that, so corrects itself. Or if it's going back, it's going to get lighter under that light sensor, so it knows it's going back and it corrects itself. And it keeps on does that and kind of just bounces around like this. And that's what these wheels are for, because sometimes it goes too far back and it can catch itself and correct itself that way as well. Another thing I might think about programming in is programming in this sonic sensor. So if it's getting too close to a wall, it'll just kill switch so it doesn't run into the wall and damage any of these cords or any part of itself. So that's some examples of uses on my machine.
Okay. Thank you.
Mm-hmm. Did that clear things up? Good.
Let us
Well,
know if there's a specific code you want to try, Jeremiah, and if we can help you make that code, we'll do that with you right here, okay? And you can just follow along. So if you want to try one of those codes, just let us know, and then Zane can build it with you while you follow along on your own, okay?
Okay.
Yep.
Has anybody else started working on their programming that could show us their programming too?
Yeah, you can share your screen, and we can help you troubleshoot your programming from that way as well.
You also have to keep in mind that there's obvious errors in programming that can happen, but there's no right or wrong way to program something. There's thousands of different ways to program something. So although I may do my programming one way, there can be 1,000 other ways to achieve that.
I have some pieces that I don't know exactly what they are.
All right, we could take a look at those.
So first I have this, it's like a chain.
Yeah, so that goes on something called a sprocket, and a sprocket kind of looks like a gear. I don't think I have any sprockets in mine, but I'll show you. It kind of looks like a gear, but it's got bigger teeth and they're kind of spaced out a lot more. But this is a gear, so imagine if I had a tiny chain, it would fit on this.
And then I have this.
So that's a vertical gear. So that can move side to side using one of these. I don't think I have one of those either.
We could look at the other kits, Zane, and see.
When we were sorting the kits, I don't think any of them had them, but I can demonstrate with one of these pieces. So here, let me. So say this was your vertical gear, right? It's long and all that. So say I had it like this. The gear, if the gear was rotating like this, it would push this way and opposite. So as this rotates, it pushes it one way, and it rotates the other, it pushes it the other way. A common thing that uses this type of mechanism is like a forklift to extend the forks out or upwards. They have that type of gearing system that takes multiple of them like this. So when like a fork lifts down like this, and then when they take the gears, it extends up like that. So that's what those gears are used for in a real life application.
And then I have one of these. I have a couple of these.
So that is not an actual piece. That's just there to hold rubber bands.
So I'd assume this one is too.
Yep. Those are used for holding different size rubber bands.
And then what's this?
I have no clue. Jane, do you know what that is? I've never seen a piece like that before. It's some sort of specialty piece.
Wow, I don't know. I have not seen that piece before.
Me neither.
Is it on the map in the kit map?
I think I seen a piece kind of like this. I think when you I can't remember, but something to do with NXT. There's one robot that you can build which has this little ball shooter.
Oh, so it's like a special add-on kit that it may have came with. That makes sense. Yeah. I think you're right, Wyatt. That makes sense.
That could be. That's my only idea. Kind of like this gear. This gear here is a specialty piece for probably one of our other kits.
Yeah, we have a couple NASA like expansion kits for those NXTs.
Caden, how's your robot going?
Mine's going good. I've learned how to turn it and stuff.
Awesome.
Good.
That's great.
Yeah.
Do you want to show us?
Sure. I can show you the program I have. Kind of just like
Oh, I almost saw your screen. Oh, I can barely see it. Oh, yeah. Okay.
You got a series of motor trends in there?
yeah.
Kind of? Yeah, I can see that.
Good deal. Is it working? Is it turning the way you want it to turn?
Yeah, it is.
Okay, good.
Good.
That's excellent.
Yeah.
All
What,
right.
are you trying to develop kind of like a pattern or something, or what's your plan for your program?
Yeah, I was trying to develop like it to turn and then go forward and then turn. So kind of like a pattern, yeah.
Gotcha. Yeah, those can be fun to plan out sometimes.
So one thing we're going to probably want to think about for this group is what's going to happen, because this fall we're going to have a robotics competition with 4-H. And it's a part of the 4-H, 4-H, what we do in 4-H is have competitions and show things at fairs, right? So we're actually going to be setting up the judging for that and organizing some sort of route that you're going to be required to program your robot to either follow or complete some sort of task, like pick up a ball and move it or something like that. So you might want to be thinking about learning some of those actions, like how to further control your robot. Would you be able to program your robot kind of like how we do when we're playing Minecraft, program our agent to follow and complete certain tasks? I don't know if any of you have done Minecraft with us, but anyway, so just be thinking about that. What is the overall goal and task that you want your robot to complete? And be thinking about maybe having it complete 3 steps, 3 major things. So like, you know, going somewhere, doing something and coming back, or going somewhere, picking something up and putting it somewhere else, or bringing it back, something like that. Those are typically the kinds of programs and things that people will program their robot for in the variety of competitions for 4-H.
Yeah, like I said earlier, another useful tool are these touch sensors, which you can kind of create joysticks with to control your robot. So maybe one controls forward and backwards, and the other controls left and right. Well, actually, you would need more than 2 of these. But still, trying to control different functions of your robots with these as buttons and whatnot.
I've been to the 4-H Showcase Showdown ones, and last year I did a forklift, though sadly it didn't work. And the year before I used their the original one they have you build, and I made it so my robot would go forward, hit a Lego brick, go forward, hit a Lego brick, go forward, hit a Lego brick, and then go forward, and for the finale, hit a water bottle with a Lego brick on top.
Yeah, how did that work out?
Really good. So the first one, I got first place, and then the forklift, I got second place, only because it didn't work.
Okay, all right. So you got a little bit of learning to do to make sure that you can get there this time and get into first place again, or at least try to place pretty well, right? You've got to work yourself up for that. And what level are you at, Wyatt? Are you?
I'm an intermediate. Also, last year I also did sumo, and in sumo I defeated every single person except one person who I had already beat and faced once. They come back in the championship, tilt the robot like a hare, and beat me.
Oh my goodness. Got some competition out there. How about you, Jeremiah? What group are you in for 4-H?
What do you mean?
Like
Like
intermediate.
club-wise or?
Yeah, like in your club, what's your age group? You're like
Well, this year is my last year as an intermediate. So
okay,
next year
so
I'm
you're
gonna be a
intermediate as
senior.
well. And then Kaden, do you know what you are?
Yeah, I'm an intermediate.
Okay, so all of you are. That's great. Awesome. Awesome. So do you guys have any more questions? Do you want to still stay on and continue working a little bit longer? See if you can solve some problems. Did we answer them? Are you finished? What do you need from us?
I need help working my touch sensor.
You need help with your touch sensor?
Yeah.
Awesome.
So what are you trying to do with your touch sensor?
I'm just, whenever I hit it, I want it to go forward, but whenever I do it, shows up with I have too many wires to play.
Do you have it connected to your machine already?
Yeah, it's already connected.
Let's see here. I've never actually done this. So touch sensor, we're going to drag that in here. So if it's pressed, have you selected the right port down here? So if you okay, let's just start by dragging in a touch sensor here. So you just go over to sensors and drag this touch sensor in.
Yeah, I've done that.
Okay. Do you have it set to the right port down here?
Yes, I do.
Okay, and then you have it set to you want right here. So if I wanted to, let's go basic move. I'm going to bring down this function down over here. Let's just act like these are two different. Don't want you there. So these are two different motors. So let's have this one C and this one B. And then what we'll do is we'll connect. You don't want these to be connected at the start.
Yeah, I have that all done.
So we want to connect these.
Oh, you want to connect those two?
Why aren't you cooperating? So can we drag out to these? Okay, so yeah, you can drag out to these using this tool out here and see if that works.
I can't get it to like stay connected to it though.
Try restarting your software. If you're having problems with your robot connecting to your software, try restarting it.
Is it not connecting to the blocks or is it not connecting to your robot?
It's not connecting to the blocks.
Let's see here. Oh, come on. So if you attach it to this starting point, can you drag out like this?
Yeah,
Just
I
straight-
can.
It won't let you drag out?
It will let me drag out, but I just can't like get it to connect to one of the blocks.
Are you dragging into, so like, is this kind of how you have it set up? You have two random motors out here?
No, I have it all connected. Like,
Is it connected to the start?
Yeah.
So if it's connected to start, it's automatically going to have those motors run on start. So that may be a reason why you can't.
Well, it's not like connected to the start. It's like not on start, but it's like on the same row as like start and stuff.
So it's like this.
Yeah.
Yes. I think you're muted, Jane.
Sorry, I was going to suggest that maybe he could share his screen to, you could better help him if Caden had his screen up.
Is that possible, Caden?
I could. Like this is how I have it right now.
Okay, so you have it. You have the top one connected to the top bar and the bottom over. So there's only two rows going right now, correct? And they're both on a connected row. All right, let me look something up here. I'm trying to look up the programming documentation. All All right, so you're gonna have to have that push sensor on both of those lines. So you should have like so you're trying to drive forward and turn, drive forward, push a button and turn, right?
Turn, then push a button, then drive forward.
All right. So have that turn programmed on both lines and make sure they're both connected to start, and then put a push button on both of those lines, and then a drive straight for both of those motors after that. So I'll share my screen again, just kind of show you what I'm talking about. Looking at documentation here. So if you see here, so this is like an example to use the touch sensor. So right here they have both their motors set up, but right here on a second line you would have a turn for two separate motors, a push, and you could even program the one that you had on the right of the push to be both motors forward. You don't have to have two separate. You don't have to have two separate ones. If you're going forward or backwards, you can use the same function for both motors. It makes it a bit easier and organized. So try that, and if that doesn't work, I'm gonna keep on looking up stuff because this is all new to me as well.
Do you know what gears would be used on these treads?
Those would have to be sprockets. What type of gears do you have? What type of these do you have? Do you have ones that have bigger teeth, so bigger parts of these?
I have, let me see.
That was a sprocket. So something that size, the one that you were just holding, that was kind of a, yeah, see, those are sprockets. So they're kind of bigger than gears. So that's what would control that chain or that belt. As long as they fit around them, all right. So those, that belt or that chain would go on something like that. Maybe you have different size one of those. Yeah, see, like that.
Let me see. I have this one, which I don't think. This one.
I think that's
This
a gear.
one.
That's a sprocket.
Which one? This one?
Yeah, or it's just a large gear. It's hard to tell. You may not have any sprockets in there, but some of them may work as the
And then I have this
sprockets. Oh yeah, so that's what I have. I'm pretty sure that's, so if you have the right gears for them, I don't think we have the right gears for them. You can put a gear in this. Well, actually that one that you have might work, but say this spot sits on the bottom part of a body and you put a gear in there and the bottom part stays stationary, but the top part can spin with that gear.
So, I got that same message. It says there is more than one data wire connected to the same input, but I have it inputted at like 1, but I only have one connected to the touch sensor.
Can I have some chocolate?
Let me look it up.
Oh. Marshmallow.
Thank you.
No, are you guys taking off, Wyatt and Caleb?
Yeah.
Okay. All right, we'll see you next week.
Have a good one. I'm looking up that solution for you, kid.
Okay.
So when it's talking about a data wire, it's talking about in the software, not something that's actually plugged in to the thing. So a data wire is that little part underneath the touch sensor that comes out. So I'm reading more on that and on how to properly connect a data wire.
Should I try another touch sensor?
Your sensor's fine. Your sensor should be plugged into the right one.
Even with the new touch sensor, it's still saying the same thing.
So let me look here.
You're trying to be.
All right. I think I may have it, and I have something for you to try.
Okay.
Let me see here. Nope, that doesn't seem to be a correct solution.
That's just what pushes it into the debug. Yep, you're right. Now there is a cost associated with using such machines, but we do have materials. Doing great. There's like one question. Because they can get you either B or J.
Dang it.
Hey,
Gotta take it all again? No, I got it. Okay. Yay. How'd matchmaking go?
Pretty good.
Yeah.
Yeah, I'm just made an ask and it was a bit late.
Yeah, or make more and make, give it away. Like, that's what I've been doing. Like, masks that I make that don't fit me, I'm like, oh, give them away.
I don't know all too
yeah,
much
you're
about
like,
the
no,
touch
I'm gonna
sensors or
do
most of
that.
these sensors on here. I know what they do. I don't know how to use them or program them because this software is new to me. So I'm looking at how to actually program them.
I'm gonna have to get going.
All right. Well, do you need any more additional help before you go?
We got quite a bit of
I
stuff.
don't.
Honestly, these matter habits, after boxes, I'm thinking about.
Okay. You think you guys can have a solid build for next week?
Or program. My robot solid built already.
Okay. So you think you can start programming it a bit more confidently?
Yeah.
Cool. Well, then you have a good week, and we'll see you next week. Okay, and I'm still looking. There's not a whole lot of documentation on it, so I'm trying to figure out how to properly use it. Of course, they don't have like any of the programming parts of it in here.
Like, if you look here.
Actually, they may have it.
Okay, on this one, we have another one.
Oh, you can kind of like break them off.
You can kind of break them off as we go, if we get full. It's maybe over here.
Oh man.
So this one has little ridges, so when it gets done, you just.
Yeah, see, this is all showing me different software. But let me see if I can figure something out in the software itself.
Did you want to keep using this I went down?
106. You know what? I'm gonna finish up alterations on this.
Okay.
Next time I come in.
Okay.
That's all right.
Yeah, I just figured since we already have like time and everything. But I'll just wipe it up real quick and put it back.
Okay.
Yeah.
Yeah.
I was just looking for something.
So I tried to run it without the touch sensor and it worked just fine without it.
Right. It's trying to get the touch sensor to link with the motors, and that's what I'm trying to find documentation on. But I may have found it. Sensor blocks, touch sensor block. Three is the block data hub, and it will open automatically when the block is placed in the work area. Data wire must be dragged from the block's output plug to another block's data hub. See, that's the thing, is like a motor doesn't have a data hub. Okay, so what you need is you need a logic gate. So I'm going to share my screen. If it's not already shared, it's not. All right, so I'm going to share it. I'm going to go here. So this is kind of your basic setup. Obviously, you have a turn right here, but this is kind of what you should have right here.
Yeah.
Can I connect these or not? There we go. So what you want in between is we're going to go to data, and we're going to go to logic, and we're going to place a logic gate here. Why are you so stubborn?
Oh, so I just need a
So you need a logic gate.
logic gate.
Yep. So if so you're gonna have it go into A, and if A is passed, and if we click this A, or maybe we have to go to B. I don't think these connect. Let me do more research because that's not working. But it says like that plug is a logic gate, which it's either going to be true or false. But my thing is how do you connect that to a motor, which I'm trying to find. Configure the touch sensors data block. Let me see. Ah, it does. Okay, so that's sneaky. So maybe we don't need a logic block. So if you press this little gray box right here, which I didn't know was a thing, you press this little gray box like that, it pops down with a big list.
Where do I press?
Right here at the bottom.
Oh, okay.
But I don't see a logic. This is frustrating because they've been out for a while, and I would think there would be more documentation on it, but I can't seem to find anything. Motor block. Configuring the motor block. We know how to do that. Motor versus robot direction. We know that. So a motor doesn't have logic, unfortunately. So how would we control? Oh, okay. Control motor power. Why don't I see that on here? Let me try a different motor function. Let me go to action, motor, and go here. Okay, so we can control motor power here. So if we go logic into motor power, what it should do. I think that connected. I'm not 100% sure. Try to see if something like that works. If you go into action and then motor instead of common and move, you may get more functionality out of that. I'll do more research on it. Oh, don't forget to toggle motor power down here for control.
Okay. That worked.
It worked? Did it go
Yeah.
the way you wanted it to?
I just downloaded it. I could try to run it.
Is it not doing it?
Yeah, I can't get the touch sensor to go though.
Yeah, let me look here.
Or
So read this part right here. So it says you'll need an NXT car with 2 motors and a touch sensor. Attach one motor to port A and the other to port C. It doesn't really matter what ports you attach to. Oh, so the touch sensor, it's in a port sensor, right? Not a motor or a motor port. It's in a sensor port. So it's got to be a numbered port, not a lettered port.
yeah,
Is
the
that
touch sensor is in a number port.
okay? So erase the rest of your program, or at least drag it out so it's not active, and try this. Obviously change your motors up here and change whatever port the touch sensor is, but try this little instruction right here.
Try what?
Try this little function right here. So just a touch and then just a forward for amount, duration amount. Instead of like, because then if that works, the same should work for your current program. Is it not doing anything still?
No, it's not.
Have you tried a different touch sensor? It may be because that sensor's bad.
Both my touch sensors aren't working. That I have.
So we know your motor's working, right? Both of them?
Yeah, both my motors are working.
Can you swap out that wire with one of your motors?
With one of my motor wires?
Yeah. Because it could be the wire too. Because everything I've read so far on how to use a touch sensor says the same thing that we've been trying.
Even with the new wire, it's not working.
That may be something we have to come back to next week, because I'm going to have to definitely find more information or try to test it myself. Actually, let me see if I can just run something like that here. I guess I could just. And move both my motors, which are going to be in B and C. So C and B, that's going to be forward for, I don't want duration. I want, actually, let's just do seconds.
Hey, I got it to work. I just had the motor plugged into the wrong port.
So the button works?
Yeah.
Okay, that's good. Yeah, it can be small things sometimes.
Yeah.
Cool. So we got that sorted out. So now you should be able to do direction that way too.
Okay. Okay, sweet. Thank you.
Mm-hmm.
That's all I needed today.
That's all.
Yeah. So thank you again.
Mm-hmm.
Bye, Kaden.
Bye.
Adios,
Bye.
buddy.
Thanks for tuning in. See you later.
Bye.